Hey guys, I'm going to briefly talk through some of the questions from the review. This covers sections R1 through R3, all of which are covered on the first quiz. So I'll kind of skip through topics, hitting a few problems each time, trying to just cover some of the major points and places where I think you might want some more information or refresher. Okay, so problem one, just talking about sets. Remember, a lot of sets is just going to be vocab and knowing what the symbols mean. So first thing, knowing if a set is infinite or finite. And we can tell this set is going to be infinite because there is that ellipses at the end, meaning it continues forever. And it doesn't seem to have a ceiling or an ending point. So it looks like we were talking about an infinite set. And is 4 an element of this set? If you look at the pattern, these are all fractions starting from 1/4, and each time the denominator is being multiplied by 3. So I don't think 4 comes up in that line, and because it's not part of that pattern, we'd say 4 is not going to be in this set. So continuing with sets, we're going to look at number 5, and you can see, hey, this is kind of a reminder of the symbology. So this E symbol and then the E symbol with the slash through it. So this first one means that something is an element of that set. And then the E with the slash through it would be the opposite, is not an element of the set or a member of that set. So you can see, hey, 3 is not in 9085. It is not one of those numbers. So we would fill it in with that E with the slash through it and choose the first option there. Okay. If 3 was a number included in there, then you would, of course, use the is an element of. Okay. Now, quick reminder about the union and intersect notation. So a upside down U, or that bridge shape, represents the intersection. So things that they share in common, and the U share is called the union, which is of course all of the elements between the two of them. And we don't have to write the duplicates multiple times. Okay, so here we go. I see that 4 is in both of these sets, and I also see that 10 is in both of these sets. And based on this, I can say that, hey, the common stuff, the intersection between these two, should actually be the set of 4 and 10, not just 10. So what do we discover? That is going to be actually false in this case. Okay, remember that the union for this would be different. That would have been like 3, 4, 8, 9, 10, and 2, right? All the different numbers that would be there. Let's go ahead and write that out just so we see that. So in this case, we would have gotten this set here. The yellow is the union of the two sets, okay? And that is 2, 3, 4, 8, 9, 10, which is all the unique numbers, even though 4 and 10 are repeated, right? And the intersection is, of course, only the ones that are in common between them, which was 4 and 10. Okay, now, of course, the notation for a subset, the sideways U or C with the underline under it, that is a subset. Okay, and then of course you put a slash through it to say that it is not a subset. So remember, a subset means that it is contained within the other set. Okay, so all of the numbers that we see here, 3, 6, and 11, must be in the right-hand side for this to be a subset. So let's look for 3. Okay, we see 3, 6, and of course 11, which means that yes, the left-handed set, if you want to call it A or B, whatever you want to call it, is a subset of the other set. So we can go ahead and say, yes, this is a subset. I'm going to go ahead and circle that. Okay, something a little more mathematical, and here is a double header for you guys. So -4 squared. Now notice the parentheses contain the negative. So of course we're going to go ahead and say this is going to be -4 times -4, which is +16. okay? If the negative was outside, that would have not been multiplied in there. It would have been 4 times 4, and then you would make it negative at the end. Okay, so 17 is actually, the answer is 16. And let's take a look at number 18. So negative 4 times 7 plus 4 divided by 2. Now, we should start by, in this case, multiplying and dividing because our exponents and parentheses are already cleared. So let's see how that works out. So we'll start by multiplying these two. Negative 4 times 7 makes negative 28. And these two we're going to divide before we add the two numbers together. So 4 divided by 2 is 2. Now we add, and we should get negative 26, and that will be the answer to number 18. Okay. Remember, guys, when you multiply and divide, go from left to right, especially when you see that actually written out division symbol instead of using a fraction bar. Okay. That's one thing that commonly gets messed up is reading it from left to right. Okay, simplifying an expression with some exponents in it. Okay, so let's see how this works out. So first of all, our exponent that's up here is going to get distributed downwards, right? This 4 can be distributed to each of the elements. So let's see what happens as this gets kind of distributed into the three elements. And the three elements, of course, are 7, a to the 13, and b to the 0. So our negative sign, I've got 7 to the 4th. A, 13 times 4 makes 52, and b is still to the 0 power. Okay, and then we can kind of just tidy this up, and that was kind of the big part of it. But as we're tidying this up, you'll see it's not anything too crazy. B to the 0. Now, anything to the 0 power is just 1 times a to the 52, and 7 to the 4th. Now, you don't have to do this by hand, but you would get 2401 as 7 to the 4th power. Okay, and now that's still negative, so of course we can clean this up a little bit more. We don't really need to write times 1, so we've got this negative 2401 a to the 52 power. Just a couple of points to keep in mind here, right? Remember that anything to the 0 power becomes 1, and when you multiply it, that kind of goes away. On the other hand, if you have this negative that's on the outside, make sure that you keep it there on the outside until the very end, okay? It does not get put to that exponent, and that means it doesn't get canceled out because it is outside of that parentheses. It's unaffected by that. Problem number 38, we're talking about finding the sum and difference of some polynomials here. In this case, there are three different polynomials, and the middle one is being subtracted. So as long as we're careful, it's not too difficult. Remember, we just have to find all our like terms, and we can add and subtract those. Now, I'm going to start by taking this middle piece, and I'm going to go ahead and distribute my negative sign in. So make that negative 9m cubed, negative 3m squared, and minus 7m. And now I can just consider everything as being added together, and it just kind of makes the thought process a lot simpler. So what we'll do is we'll start with our highest exponent, 3m to the 4th, and then we'll keep going just looking for the next highest exponent. I don't see any matches with that. So here's negative 9m cubed, again, no match. And then we can go on to the next piece. So here we go, negative 3m squared, another negative 3m squared, and then an m squared. So for this one, I've got negative 3, another minus 3, and then a plus 1, which will, of course, give me a negative 5. So I've got minus 5m squared, okay? And then we'll look for our last one, and that is m. So we've got plus m, minus m, and then minus 7. So if we want to write it out, we've got plus 1, minus 7, and minus 1. And the ones basically cancel out. We get negative 7. So I have minus 7 m's left. And you can see I've used all my terms now. So my solution is this 3m to the 4th minus 9m cubed minus 5m squared minus 7m. And you can see by kind of checking our exponents as we went, by going in order of the exponent terms, we didn't have to rearrange it to get our final answer in standard form. So finding the product, guys, with binomials, you know that we can use our FOIL method, first, outside, inside, last, and it just tells you which terms to multiply. So let's start by multiplying the first term from each of these. So 6v times 7v makes 42v squared. We've got 6v times 3 being the outside terms plus 18v. Negative 1 times 7 minus 7v. And then negative 1 times 3 minus 3. Of course, most of the time, not always, but in simple binomials, the middle two terms are the same, so we will combine them together. So here's what we've got. 42v squared. 18 minus 7 is going to be 11v minus 3. And there we go. That is problem number 39. Okay, now what about using the binomial formula in order to square rather than using FOIL? Okay, so once again, remember the binomial formula, how does it go? Well, if you have something like this, a plus b squared, it equals a squared plus 2ab plus b squared. Okay, and I purposely didn't use x and y again because I know our problem has x and y in there. But basically, what we have to understand is the first term, the first piece, is going to be our a, and the second piece will be our b. And we can just kind of fill in the right-hand side of the formula pretty simply. And we could say, okay, well, I've got 2x squared plus 2 times 2x times 9y plus, and then 9y squared here. Okay, and once we've written this out, we can kind of tidy it up into our final answer. So 2x all squared is 4x to the second power plus 2 times 2 times 9 makes 36xy plus 9 squared, 81, y squared. And this is, of course, our final answer. Okay, so once again, if you're not sure where we're getting our pieces from, this is A, B, and then B, right? So each of the n terms is squared. As a quick reminder, there's also the A plus B times A minus B formula. You should know this one. Very simply, A squared minus B squared. Okay, that one's super important, so keep that in mind. So 43 now, guys, following kind of similar logic to the previous problem we did, and using that same formula. Remember, A plus B squared is A squared plus 2AB plus B squared. Okay, and we just have to identify what A and B are, and we can fill in the formula. So in this problem, of course, 2p minus 4, that's going to be my A, and q will be my B. So we can say that's A, that's B. Let's fill in our formula here. So we've got A squared, so 2p minus 4 squared plus 2 times 2p minus 4. So that's 2a, and then of course times b, which is q, and then plus q squared. And forgive me if my q's look a little messy here. So now, again, once we've got this, we can simplify it down, combining whatever pieces we can. Now, this very first term is kind of interesting. It's another binomial squared, and we could apply the square formula again. We can FOIL it again. But either way, you should get this. 4p squared minus 16p plus 16. Then the middle term here, we can distribute out each piece, and we should get this plus 4pq minus 8q. And then, of course, my final term at the end, q squared plus q squared. So this form that we have, the blue, yellow, red writing, is actually fine as our final answer. We could try to rewrite it in a different order if we really wanted. We could put it in q descending if we wanted, starting from the red q squared and working our way down from powers of q. Currently, it's kind of written in just the order that we got it in. And there are a few things you could do with it. You could move the 16 to the end, trying to get it in order of the powers of p, or whatever you want, really. But for this problem, we can kind of leave it in this form. Usually we do try to standardize it a little bit more, but with multiple variables, it can get a little bit kind of complicated. Okay, 46, a division problem. So division, guys, remember, is kind of the more tedious of these. And there's already kind of a danger here that we should be on the lookout for. And that is that there's a missing term right here, right? So we need to make sure that we fill that in with 0x. So let's go ahead and set up our division and solve this. And we'll use long division, as that is what we've seen before, and it's kind of the more powerful of the two tools. So we've got x minus 2, our divisor, on the outside, and we're going to divide 3x cubed minus 2x squared plus 0x plus 6. Now notice we filled in the 0 because we wanted to make sure that we do not leave an empty space for a term, okay? And that will keep you from having any placeholder mistakes and accidentally canceling the wrong term, all right? So let's start by figuring out what our first value is going to be. So we need to go from x to x cubed, right? So we know we're going to multiply by x squared, and I need to multiply by the number 3. So we'll take both of our terms here, x and negative 2, times x to the, or 3x squared. So multiply 3x cubed, and then negative 2 is minus 6x squared. Now notice the first term should always match up. That's how you know they're going to cancel. So we're going to subtract this. And I usually put parentheses showing like, hey, I'm subtracting this whole thing. Cancel these first two terms. Negative 2 minus negative 6. This becomes plus 6, right? So negative 2 plus 6 is going to end up being 4x squared. And we'll slide this 0x down. And then we're going to repeat the process, right? So again, x going to 4x squared, we're going to add or multiply by 4x. So we've got 4x squared, and this is going to become minus 8x. And again, following our same procedure, subtract. First terms should always cancel. Negative 8 subtracted becomes plus 8. So we've got 8x plus 6 when I bring down that last number. And now we'll do the process for the last time because we're definitely out of numbers after this. So x to 8x plus 8, right? So we've got 8x minus 16. Again, once you have this bit, you're going to subtract, okay? First terms cancel. Minus negative 16 becomes plus 16, and I've got a remainder of 22, it looks like, right? Now, key thing to remember, guys, we have to be able to format our answer correctly once we've got this. So start with what we wrote here at the top, 3x squared plus 4x plus 8, and then bring our remainder as a fraction, plus 22 over our divisor, x minus 2. Okay, so this is our final answer with the remainder 22 at the end. Okay, so division can be a little bit tricky, guys, mostly because we have to remember to watch out for these placeholders. Make sure everything is in standard form, that it's in order, and watch out for these negative signs. When you subtract negatives, remember they flip to being addition. Okay, if you're careful about those, though, division is not hard at all. Okay. Okay, as a little aside, looking back at problem 45 on the review, you'll see this division problem, and it's kind of just a fraction. And If you tried to set this up using long division, what you'll notice is you need to fill in a lot of terms on this, like 0x squared plus 0x plus 0, right? Like we got to fill in all of those missing spots. Not to mention on the top piece also has missing terms. We've got 0x to the 7th, then we've got 0x to the 4th, and 0x squared, 0x, and then of course 0. So I mean, we got like a ton of missing terms here. Can we somehow beat this rather than trying to set up long division with this? And the answer is, of course, absolutely. We could ask ourselves, can we reduce this fraction? Do all of these terms divide by the same value, right? So what I'm going to tell you is look for a GCF on the top and see if you can reduce this fraction, right? So you can absolutely do it using division. You could also do it by just reducing the fraction, which will probably make a lot less work for you. So that was just kind of a hint for you guys on number 45. Don't think that you have to do long division on that one. Okay, awesome. Besides that, happy studying and good luck, guys.